stand way over
So,
here.
welcome everybody. This is the Cybertuner class, and it's called Cybertuner Tames the Comma of Pythagoras. And the reason we did that is because we're really enamored with our new OTSP tuning style, and we think that that really does deal with the comma of Pythagoras. We'll get to that in more detail as we get to that part of the class. Just to know, since Norfolk, Dean and I have worked on OTSP and made it better. It's now the default for easy mode is now OTSP. And since last summer, there have been 10 releases of Cybertuner versions in the App Store. You know, internally, we've probably had 100 of them that we've worked on. But that you've seen are 10 of them. So we're constantly working to improve things. We've improved the spinner. We've improved the note switcher. Would you like to talk about the note switcher for a second?
Sure. Pianos are really organic, and it's difficult to get the note switcher, automatic note switcher, to automatically note switch every time. Our previous versions, more than 6 months ago, automatic note switched really well. I give it an A minus. It was
that's an A.
It got an A minus. It did pretty well. It was at 98%. About once maybe twice a piano you'd get a false note switch. Our current we spent a lot of time. I actually have a Yamaha MX100 right next to my development station. We're using that to test the note switcher, and the current version is at 99.8. That might not seem like a lot, but that means instead of 1 or 2 times a piano, you're only getting a false note switch maybe every 5 pianos or 6 pianos, something like that. So basically, that little 2% where it was false note switching we've gotten rid of 90% of those false note switches.
What did you change?
We worked hard on that. Because we're running on almost always dual CPU computers, we're running our DSP in both dual CPUs. It gets a little geeky, and we're running multiple filters on both sides of the main filter now, so that are dedicated for note switching. So they're really good at it, basically. And so it's running a little more processing in the background, but it doesn't matter. We have so much horsepower, but we're taking advantage of that horsepower now on the iOS devices.
So this is fortunately, he pays attention to these details and we don't have to. But we really are paying attention to all of these details. So just a couple of things before we start. I'm Carl Lieberman. I'm an RPT from Venice, California. This is Dean Rayburn, the creator, the programmer, Mr. Cybertuner himself, and we're very lucky to have him here.
I'm from Cedar Springs, Michigan, and most of the time. And we're going to be showing you a lot of aspects of Cybertuner, but let's do a little bit of survey to see who we have here, what kind of experience levels we have. How many folks do we have who use Cybertuner regularly, have it on a daily? How many folks use some other tuning device? We have a couple. How many folks tune with their primary tuning device, which are built into your head here? Everybody should be putting their, okay, how many tune only with their primary tuning device, your ears? Okay, we don't have any only ear tuners. Okay, so everybody needs to be tuning with their ears to some degree.
Is anyone here like a brand new iRCT user?
Yeah. Really? Okay.
But you've been using it, okay. Excellent. So, go ahead.
We're gonna start out, because this goes on YouTube, and we get like thousands of views literally over the first year when it's out there. We have people who've never used it and have no idea what we're talking about. So we're gonna show you some basics for starters. We're only gonna spend about 5 minutes, but you may learn a little tip even in the basics. So as most of you know, Cybertuner has several modules. The primary module that you use when you open Cybertuner is called Chameleon. To get started, we want to record the tuning characteristics of this piano. We're going to hit the record button right there, and we're going to play the 5 or 6 notes on the piano. I'm just going to play one. Let the note up. So I'm just following the instructions on the screen there to let the note up when the hand disappears. And we've got a little number at the bottom. It says 0.04. We call that variance when we're in advanced mode.
We'll explain it later.
We'll explain that a little bit later, but I'm not going to go through recording all the A's. But that's essentially how we do it. Record those 5As takes about 2 minutes.
Dean, do you treat them all the same, where you play them one time, or do you treat any of the notes differently?
Actually, this might be a tip that you haven't seen before. When you get to A5, sometimes A5 is a little squirrely and it dies out a little fast. And if it asks for A6, same thing. You can play A5 twice, or you can even continuously play A5. And same thing with A6, and sometimes you'll get a better reading. But our goal is to get as low a number as possible within reason. If you get down to 0.10, 0.15, anything below that's probably not worth redoing. So I'm going to switch gears just a little bit. The version that's coming out hopefully later this month, it's going to be for iPhone only. August, we're hoping for the iPad native. But one of the features we've added is something that Apple allowed us to do a little while ago, and that is add Touch ID for CyberTuner. I know one of our biggest support calls is I forgot my password. And we help you. We're happy to help you help you out with that. But if you can't get a hold of us, or you need to do it right then, we've given you the ability to do it yourself. With most of the modern devices, you can program I've programmed all 4 of these fingers into my devices so that I can, if I get cut or something, I can use any finger to get into it. If I forget my password in CyberTuner, all you do is I'm going to do it right now. I'm going to put my thumb on CyberTuner on the
home button.
It's asking for Touch ID for CyberTuner, and there we go. And what it did is it stuffed my password into the password field right there. Now, if I forgot my password, I can hit the Show button right there, and I can see my secret password. That's actually not my password, but it'll actually retrieve your password and show it to you as long as you have your thumbs, as long as you set it up to use your thumbs. So, or fingers, or any finger. You can actually use any body part in theory.
So I'd like to say this is the headline. This is the headline for CyberTuner. It has been for many years. It keeps getting better. But the most important thing, it's like the holy grail of piano tuning, is I want to just sit down, I want to tune the piano, and I want the piano to be in tune. Okay? CyberTuner can do that. If you're within 5 cents and you're doing concert smart tune mode, it's going to be good enough to play a concert on. I work in a performing arts center where sometimes the piano is at 440, sometimes it needs to be at 442. I have no problem in one pass bringing the piano from 440 to 442 and doing a touch-up tuning before the concert. It's very, very accurate. If you're in someone's home and a piano is 15 to 20 cents flat and you're tuning it in Smart Tune, you can do one pass and walk out the door. You're probably going to go through and orally clean up any unisons or something like that for 5 minutes, but you can walk out the door after one pass. I mean, aside from doing good work, which of course is what we want to do, you're trying to make a living. Speed is very important. We're selling our time. So if you can get things done faster, you're going to make more money. The tool pays for itself very, very quickly. Yes?
How do you get into Smart Tune up there in the top right corner?
Oh.
This is kind of a beta version, and we're working on this. I just actually created this for the class because we're trying to emphasize that this is set to Pure 12th. We're trying to emphasize our version of Pure 12th is really smart. We're actually thinking about calling it Smart 12th because it does more than just tune Pure 12th. We pay attention to many different intervals and many different levels of those intervals. For instance, a 12th is a partial coincidence of the third partial beat of the lower note of a 12th beats against the fundamental or first partial of the upper note. Well, that's in this part of the piano. That's really important relationship. When you get into the bass down here, those aren't the loudest partial pairs. CyberTuner's calculation actually uses a 6-2 partial pairing, gradually feathers into a 6-2 12th in the bass, and it feathers on a really big pianos. It feathers into a 12-4. You can see the 3-1 relationship between the partials. 12ths are just like octaves in the sense they have coincidental partials. Octaves you've heard of 2-1, 4-2, 6-3,
I think you
and
just
so
wanted
on.
to know how you get to Smart Tune mode.
Oh, I gave you the complicated answer for a simple question. Sorry. Okay. More than you wanted to know. Okay.
Well, we'll get to all that in incredible detail. We'll get to all that.
Okay. we're going to show you actually how the spinner works in a minute. Most of you know, but we're going to do a quick demo. Just as we're going here, what you're seeing is a little bit different than what you're seeing on your iPad. This is an iPad native version that's coming out very, very soon, and it's going to be a free upgrade for all our users. We've been working for the last year on this in my spare time, and then for the last 2 months full-time on this. It makes much better use of the screen space, and it does a lot of things as far as the interface. All the same features are there, but it looks just a little bit different, and you'll be seeing that as we go.
So do a calculate and take them into SmartTune.
Calculate, graph, and I have SmartTune set up as my default, and then in the iPad native version, we're looking at the same tuning modes you're used to looking at, except now we can see, just like kind of like in settings, you can see the primary stuff on the left, we call the master stuff, and then on the right, the details for that particular thing you have chosen. So this is way better use of the screen space for an iPad. We're still optimizing it and beta testing it. We think about a month here, so we'll have this finished. But it's perfectly stable, and we're improving it as we go.
So is this only going to show up on iPad versus my iPhone?
That's correct. The iPhone's just too small. The iPhone, we have a few improvements that are coming out in parallel for the iPhone, but the iPhone will be almost the same. Yeah, even the Plus. It's possible to put what's called a split view like this on an iPhone Plus, but we still think that that's a little bit too small of a screen for most of our users. On an iPhone Plus, I could actually give them in a future version the choice if they want a split view like this. But for a lot of users, this is too small even on a Plus. On an iPad Mini, this is too small for a few people, so we've raised the size of the fonts there and everything.
So I just want to reiterate: most of you are iRCT users. Some of you are not. The headline is, instead of tuning the note to where we want to tune the note, where we want it to be, we tune it to some imaginary place where it's going to settle to exactly where we want it to be. Every tuning is a pitch raise. If it's 5 cents off, it's a pitch raise. If it's 15, if it's 75 cents off. And so we can very accurately predict, and for this to work, you can't throw CyberTuner a curveball. CyberTuner expects you to tune from the lowest note on the piano to the highest note of the piano. Or you can do the bass in any order. You could start at the lowest note on the tenor bridge and go to the highest note. But you can't strip mute a piano and tune center strings and then come in and do left strings and right strings. We can argue whether that's a good or a bad way to tune a piano, but it's not what CyberTuner expects. And if you don't do what CyberTuner expects, you won't get the predicted results that you're expecting to get. So the big thing is just this, the fact that we are anticipating where notes are going to drop. I can't tell you how special that is.
Let's pull up that graph that shows that, how we do that. It's a graph that has the overpulls and our tweaks put into the SmartTune.
Absolutely.
Because that goes right along with what you're saying.
Let's go to that right now. And
so we've all done this. All of you who are using CyberTuner have chosen the different treble struts. This looks a little different, but it's the same interface you're using right now. Choosing which note are right next to the plate struts. The reason we do that is because it gives the CyberTuner a little bit more information to tweak the overpulls. Now this is a chart of the standard overpulls for pitch raise mode without any tweaks, and it's pretty smart, but it doesn't know where anything but the lowest tenor note is or the bass treble break is, and that's this cliff right there, and it kind of guesses at everything else. But in SmartTune mode, so let's pop it over to SmartTune mode here.
Just slide the next one.
In SmartTune mode, you've already told it where all those plate struts are, and CyberTuner's tweaked. It does a much better job at tweaking all those little points. These are the points where the plate struts are, and it's going to tweak those by several percentage points to get you. It looks like it's going to be a rougher tuning. This is actually going to be a smoother tuning because it knows what the effect of those plate struts are, and it smooths out the tuning, so the final result is
this is why
right
we
where
can
you want
do
it
it
to be.
in one tuning. We're taking all of this into account.
We also take the program also takes into account the level of inharmonicity and the piano size, putting those together. And large pianos need less overpull, small pianos are weaker and they need more overpull. And it knows that in a number of graduated steps. So I'll put it in a nutshell.
Back to your initial sampling, it's a green light if it's above a certain, it's a red light if it's below.
Green, yellow, red.
Yes.
Point 19 and below, green. Point 20 to point 49, yellow. Point 5 and above, red. Just like a stoplight, they should all be green. In fact, look, let's just jump to this right now. It's because it's come up. Let's go to this as the topic in sequence. Yes, exactly. You just stop, you collect your check, and you don't do anything else. So I just sampled this piano right now, and these are the sample numbers I got. Me personally, I work on pretty good pianos a lot of the time. I want to get green samples all of the time, okay? But we're going to actually go into some detail in the next minute about what these numbers mean. You can accept the yellow number if it's 0.24 or 0.26. If you can't get better than yellow, then accept yellow. Almost never accept red, okay? Now the point is these numbers, let's talk about these numbers here. So when we do a sample, here we go. When we do a sample and we play those 5 A's, we're listening to something. What is it that we're listening to? At A4, we're listening to the first, second, third, fourth partials. At A3, the first, second, third, fourth partials. At A2, the second, fourth, fifth, and sixth. At A1, the fourth, sixth, seventh, and 10th. At A5, first, second, and third. That's what it's listening to, okay? What these variance numbers are is now, this is the note A2. I don't know if you can see the numbers, if they're big enough yet. And what happens is, at the second partial, we play it 3 times, we get 3 numbers. At the fourth partial, we play it 3 times, we get 3 numbers. The number that you see displayed in that box is the worst discrepancy at any partial of the 3 different samples. So what you're seeing here on the 6th partial, the worst discrepancy was between 0.72 and 0.94, it was 0.22, and the number that would show up in the circle would be 0.22. Yep. But remember, this error is plus or minus. You're taking a midpoint of 3 samples. So to have a variance number of 0.22, it means you're plus or minus 0.11 of perfect. When you're within 1/10 of a cent on your samples, you can believe in your samples. That's why it's not worth your time. Some people, they get 0.15 and they say, no, I'm going to sample it again. I want to get 0.06. It's a complete waste of time. Once you've got green circles, declare victory and move on to the next step.
To put this in perspective, the best tuner on a good day, the limit of their hearing, the difference in pitch they can hear is right about 0.15 with an extra cup of coffee. They might be able to convince themselves they can hear 0.10, but I doubt it. I've tested a number of tuners, CTEs in the examining room. That's their limit, right around 0.10 to 0.15. They can reliably. I've seen them reliably be able to hear 0.15. 0.20 is easy, fairly easy, and that's in the middle of the piano. So 0.2. So what I'm saying is, if anything below 0.15, 0.20 variance, you're good. You won't be able to hear those differences at all. So there's such a small difference. So why is there a variance anyway? Why can't we get 0 variance and get perfect samples?
Because you didn't do a good enough job programming it.
It was my fault. Actually, I'm going to blame it on the piano. These pianos, and this is true, the pianos are so organic, and we're also going to blame it on the piano tuner, me, Carl, you, because we're not machines. We can't play the note exactly the same loudness every time. That's where the variance comes from. The organic piano and the human beings. It's not something that can be duplicated every time digitally. It's not a digital thing.
Well, I would say I've done some testing on this. I think a lot of it is the boundary conditions. If you're getting very high numbers on your variances, if you will lightly seat the strings at the bridge pin or lightly tap the bridge pins themselves, I think you'll lower your variance numbers. A lot of what you see when you see a higher number is there's like a wiggle at the back boundary of the string, and it's putting out kind of impure information into the tone.
That's
and you
true.
can sort of hear really good pianos when you play them and you're doing the sample, the tone is like really, really solid and steady. And crummy pianos where you get bad samples, it kind of is wavering. You know, you can hear that.
But that's the organic piano again.
Right.
Again, no piano's perfect, and and you can definitely improve it by getting seated strings and quality bridges and down bearing. All those things get you 0.05 to 0.10 in variances and get you good quality samples. The reason we want such good quality samples, the reason we fuss over this, is because your whole tuning is based on that. And we want to be able to trust our samples so that we can trust the tuning that it calculates.
So I'd like to get into the meat of what the class really is. You know, and we've created, we're not the first to invent it. People have been doing pure 12th tuning for a long time. A lot of people have understood that there's something special about this interval. But we've really made a very accurate dynamic model for OTSP. What is pure 12ths? Why do we care about it? Okay, I'm gonna have your eyes glaze over a little with some tuning theory, but I think it's good to know this. You know, the Pythagorean comma. A comma is a difference between two sets of intervals. The Pythagorean comma, or also called the diatonic comma, is the difference between tuning octaves and tuning fifths. And if we tuned 12 octaves, if we tuned 12 fifths, the ratio of a fifth is 3:2. If we started on the first one, the 12th one would be the starting frequency times 3/2 to the 12th power. And if we if we doubled every octave for 7 octaves, it would be 2 to the 7th. And the ratio of those two things is the Pythagorean comma. At A4, on a piano or on any instrument, over 7 octaves, the fifths come out 23.46 cents sharp to the octaves. I think most people are aware of that, the fifths and the octaves. And this was not developed by Pythagoras. It's named after Pythagoras. It was first discovered in the West by Euclid around 300 BC, and he named it for Pythagoras. It was developed independently in China around 122 BC, and it was named by a collective of mathematicians. So this is sort of something that people have noticed for a long time, and in essence, all of the last 2,000 years of tuning has been how to deal with this comma, how to deal with the fact that the fifths and the octaves don't line up. And we've had mean tone and just tone and, you know, a well-tempered. We've had a million different approaches. And how is the best way? And the reason we say Cybertuner tames the comma of Pythagoras is the way that we're going to tame it is by tuning pure 12ths. Just a thought experiment. For most of you, for most of my life, equal temperament meant pure octaves and tempered fifths. And if you tune pure octaves, you temper the fifths by 1.96 cents, and it works out.
2 cents.
2 cents. Well, 1.96 times 12 is 23.46.
Right.
And if we, as a thought experiment, we could have pure fifths and we could temper the octaves. And if we did that, we'd have 3.35 cent wide octaves, a very wonky octave, okay? So nobody does that. There are people who talk about tuning pure fifth tunings, but if you come right down to it, it just really isn't a good sounding tuning. The octaves are way too ragged.
Usually the pure fifths folks are tuning them almost pure, because if you tune them pure, the octaves are too wild. So they're tuning them so the beat on the fifth is minimal, and then the octaves, even then, are a little bit too wide, but not quite as wide as they would be if they were tuning actual pure fifths.
So what's so great about pure 12ths? Aside from, first of all, 12ths are in almost every chord. Unless you're playing Hanon Book 1 and you're playing in the middle octave, you're playing a little bit wider. You generally are going to have a 12th in every major or every minor chord. It's a very common interval. It's there. And so if it's a very pure interval, it sounds really good. But here's the other thing. Remember I said you could have pure pure fifths and not pure octaves and vice versa. What if we split the difference? What if we put half of the error on the octave and half of the error on the fifth? And we expanded the octaves by 1.23 cents, and we contracted the fifths by 1.23 cents. And when you add them together, the 1.23s cancel out, and you get a 0 12th. That's what a pure 12th is. It's got an equal beating octave and fifth within it. And it really is, instead of all these beats being there, all of a sudden there's this beat at one speed, and that's for both the fifths and the octaves. So we really think, just in terms of tuning theory, pure 12ths really make a lot of sense. People have thought about this for a number of years. People have tried to tune in pure 12ths, but it's really hard to do. This is something that the precision of a computer allows us to do, and it allows us to do it for the different inharmonicities in the different sections of the piano. It allows us to blend it with the smart tune, and at the same time that we're compensating for how one note affects another note, we're also compensating to try and create these pure 12ths.
OTSP does. That's what it's about.
That's what OTSP
Yes.
is about. And how many people here who have been using OTSP?
How many people have been using Smart Tune for the last few months? So if you've been using Smart Tune and have reasonably recent version, you've actually been using OTSP. It was in the release notes, full disclosure, it was there, but you've been using
Not
pure
smart
12ths
tune.
for the last
Easy
few months.
mode you're talking about.
Easy mode, yeah.
Yeah, not smart tune.
Sorry. If you've been using easy mode, you've actually been tuning pure 12ths for the last 2 months and not knowing it.
So I would encourage you, we used to deal with the break by having this OTS-S and different ways for going across, and we had the 1 through 9 octave styles, tuning styles, for how wide we made the different partial pairs in the octaves. This kind of supersedes all of that. And what I've found, I think what Dean has found, what a lot of us who are using this every day have found, that it's very dynamic. It's good on big pianos, and it's good on small pianos. It's a very adaptive situation. One of the things Dean and I are going to work on later this week is on kind of tweaking it a little to make it a little better on small pianos. If there's anywhere where I don't think it's quite optimum, it's on small pianos, but I think we can make it
It's
better.
a very small tweak.
It's a small tweak, but all
We're
of these
working
are
on it.
small tweaks. How small? I'm talking about spinets, consoles, really bad grounds. Okay? I'd like to
Really-
show you.
Really high intensity pianos where you would have difficult tuning them by ear. The Pure 12 does a really good job, but we think we can do just a little bit better.
So
Octave tuning style.
So, I want to get across to you, this is a very subtle thing. I really believe in pure 12ths, and I hope that if you guys use it, you'll come to enjoy it also. But it's not that you've been doing bad tunings before when you were using the numbered octave tuning styles. The difference between OTSP and OTS4 or something like that is measurable, but it's a subtle difference. It's a small difference. And I'd like to show you exactly what that difference is and what you will hear orally. So for instance, this is a graph of a Steinway D where I work at Performing Arts Center, and this is if you were to tune it with OTSP. This is what the tuning would look like. And I'm going to toggle back and forth between OTS7 on this piano and OTSP on this piano. And so let's look at it. This is in 7. One of the first things I would say is look at the C8 line. It goes up to about 48 cents sharp, okay? All the blue line all the way to the right at C8, we're at about plus 48. When I calculate the same piano, same samples on OTSP, I'm around 55. So one thing that happens with OTSP is the high treble gets a little bit more stretched.
On big pianos.
On big pianos, on most pianos actually though.
On most pianos, but what we found is if you tune, what CyberTuner does on big pianos is it tries to tune the cousin of the 12th, which is the 19th, 2 octaves and a fifth instead of an octave and a fifth, on the very high end. Because these pianos like Steinway D sound great and can take that. They can tune up to the 19ths in the very high end. CyberTuner detects whether it's a big piano or a small piano. On those small pianos, they just can't take that. So CyberTuner is going to stick with pure 12ths on small pianos. On mid-sized pianos, it does something in between. So, and it does the right thing for almost every piano up in the high end. And you can still adjust it, and we'll show you how to do that too. So
So let's look at the red line with the 2. This is for 7. This is for P.
It's a
Notice-
very subtle difference.
Very small difference. It's a little bit sharper in P, but almost not noticeable. Let's look at the 5 line, which is coming across the break or right above the break on a Steinway D. This is, I'm sorry, there. This is in 7. This is in P. Notice it's a little bit sharper in P.
That means less stretch in the bass.
So one of the things that happens, and if you look at the 6 line, this is in 7, this is in P. This is in 7, this is in P. Again, it's a little bit sharper. The same thing for the low bass. This is in 7, this is in P. What I've noticed orally, now that I've been using OTSP a lot, so OTSP is kind of lifting the bass a little more than we're used to and lifting the treble even more than that. But where you really notice this is as you play intervals across the break, fast beating intervals, thirds, 6/10ths, they beat a little bit slower. We just kind of slowed it down a little bit across the break, and in a way put OTSP is deceptive. When you think pure 12ths, you think, oh wow, there's more stretch everywhere. We're tuning these wide 12ths. But in the middle of the piano, it's actually a little bit less stretch than you were accustomed to.
It's fairly middle of the piano to the bass. Pure 12ths is actually fairly conservative compared to most what most tuners want to hear. So it's not a wild, wide stretch that you might think it is.
It gets up a little higher in the treble. So I'd actually like to play something for you. I'll just make a slight thing. I had 5 minutes to do this tuning here, but I did a little tuning before you guys came in. And I'm going to ask you to listen to this. I always used to check my tuning. When I finished the tuning, I would always play every note and obviously listen to every unison. And then I used to start at A0 to C sharp 2, and I used to play chromatic major 17ths, and I'd play them from the bottom to the top. And that, if the unisons were good and the 17ths were good, I sort of declared victory and said, what a great tuning I just did. And now that I'm using OTSP, I've kind of changed my oral check a little bit because I'm really wanting to pay attention to kind of the octaves and the fifths and the 12ths. So what I'm going to play for you, this is something I usually play chromatically. I'm just going to play it for C. I usually play 1-1-5-1-5. In other words, C1, C2, G2, C3, G3. And in there we have 2 12ths, we have 1 19th, we have 3 octaves, we have 2 double octaves. So it's the sort of thing that normal people, if they hear anything other than unisons, they're hearing the octaves in these fifths and 12ths. And so I'm just going to play this for you and see how it came out on this piano. I think you would say those are really clean, okay? And I think that's part of the magic of OTSP is by really locking in these 12ths, it kind of knits the whole piano together. And that's what you're really trying to do. Yes?
Now, is that with the concert mode or is that with the select?
Well, no, I tuned these with concert fine mode. I had 5 minutes, and I just jumped on it. But there wasn't a lot of rebound. Some of them I moved a couple of cents, and if I look at it, I may not have a full blush on these notes. I may have a partial blush. They're pretty well locked in. Orally, it sounded really clean to me.
So fifths and 12ths and octaves, that's all great. But there's other intervals that as an oral tuner, we want to make sure that sound good. And there's other problems we want to solve. Well, our pure 12ths calculation is built on top of the smarts that Chameleon's we've been working on for many years, and that is choosing the right partial to go across the break. Cybertuner knows where the break is, and it's calculating the for smooth intervals across the break by using the right partial relative to how inharmonic the piano is, and so on. And it's still using that in addition. And pure 12ths is built on top of that. So you may hear, if you listen really closely or do virtual measurements, you may hear pure 12ths just a little bit wider or narrower almost perfectly pure. And the reason is, you'll see those, is because there's thirds, third, tenths, 17ths need to sound good. Parallel thirds going up the piano, parallel tenths still needs to sound good across the break. And Cybertuner's aware of that. That 12ths are not the only thing there is. 12ths are in pure 12ths tuning. In our calculation, 12ths are our measuring stick. They're our goal, and they're our first priority. But very, very close behind that is all the other intervals that we want to listen to. So we haven't forgotten about those.
So a second thing, a new feature that we added this year. How many people have ever done a pitch lowering? The pitch is too high, and you're using Smart Tune, and do you think it comes out as accurately as the pitch raises come out? Have you had? It hasn't come out as accurately. Okay, that's been my experience also, Dean's experience, the beta tester. So what we've done is we've kind of tweaked the underpulls so that they're different than the overpulls. In other words, it's not completely symmetric now. It used to be that pitch lowering was just a mirror image of pitch raising. One of the things we found is that technicians use different tuning hammer technique when they're raising and when they're lowering. But above and beyond that, just think of the physics of the piano. You've got down bearing on the bridge. The strings are pulled tight and there's a downward force vector pushing down on the string. When you over pull a note and the note is dropping, it's dropping in the same direction as the force on the bridge. It's dropping in the same direction as the load. When you are doing a pitch lowering and you lower the pitch, it's rebounding to where it needs to be, but it's pushing against this load. One, it's got a hand on your back pushing you as you go. The other has a hand on your chest impeding you as you go. That's what really makes it difference between pitch raising and pitch lowering. We've taken that into account, and we've kind of made the pitch lowering factors a couple of percent less. We've also given you the ability, if you consistently are doing pitch raises and you're ending up a little sharper than you want to be, for your technique, you can go in and tell it to undershoot now by 1 or 2 or 3%, and you can end up exactly right. When you're doing pitch lowerings, if you're consistently ending up a little sharp or a little flat, there's a separate control for pitch lowerings now where you can customize it to your hammer technique. We feel that, some people, when Dean really created these overshoot factors, they were based on him tuning the first string, stopping the spinner, tuning the second string by ear, tuning the third string by ear. That's the gold standard way to do it. Some people tune that way. I personally don't tune that way. I stop the left string, I pull, and I actually leave it a little bit sharp. I tune the center string by ear as a unison. It's coming down. I tune the third string, and I've got a blush when I finish the 3 strings of the unison. And then I move on to the next thing. So I tend to end up like a center 2 higher, probably, than Dean does.
For your procedure, you probably need to set this slider right there at a -1 or 2 for that.
Well, what I do is I pitch raise I set my target for plus 1.5. If I end up at plus 3 at the end of having done it, I'm in hog heaven. I never want to be at A440. I always want to be a little sharp. I'm working on pianos where there's stage lights. Stage lights, as a rule, will lower the pitch by 3 to 4 cents. Lots of times in concert situations, there'll be a rider, and they'll say, you must tune with the lights on, okay? I basically disregard instructions like that. I don't like to tune with the lights on. It's uncomfortable. But if the lights are on, I don't turn them off. In other words, I never change. Whatever the situation is with the piano when I get there, I try to change it as little as possible. But you should understand that if you're on stage and you're not a couple of cents sharp, you're going to be a little bit flat. So it's always good to be sharp. And then when you're working on pianos regularly, as a general rule, I would say to you, no one has... I've worked on hundreds of recording sessions, thousands of recording sessions, and I leave my pianos 3 cents sharp. I've never, ever, ever had someone complain and say the piano's a little bit sharp. If the piano's 1 or 2 cents flat, I assure you someone is going to complain and say the piano is flat. If usually in stage and recording situations, you don't have a lot of time. You're moving fast. If the piano's a little sharp, it's easy to do a fast tuning on it. If the piano is exactly at 440, it's harder. If it's 1 cent flat, then you're into this fudging type of thing. So I encourage you to all leave your pianos a little bit sharp. So that's why I don't care if I set my target at 1.5 and I end up at 3, I'm a happy camper.
1.5 or 3
cents sharp.
Okay.
In other words, because I end up a little sharper than I should because of the way that I zero.
So you're setting.
And so how do you set that to get the flush? 1.5 cents sharp.
So you're setting cyber ear to like 1.5 cents or something like that.
Yes, in other words, I'm making my global pitch plus 1.5 cents. Everyone is familiar with adjusting the pitch in cyber ear. This is a very important thing. I want to say to everyone, I believe in Smart Tune, I believe in Concert Smart Tune, but in a way, we're prisoners of getting too much information. In other words, if a piano, when I come to a stage piano, and if I set it for Concert Smart Tune, every note that is off by a cent, it's going to be magnified, and it's going to be telling me to do a pitch correction for this note. Okay? It's overkill. When I come to a piano that I do regularly and it's fairly stable, I use Concert Fine Tune. And if I come to a unison that's rock solid and the note is off by 1 cent, I leave it alone. Good tuning is stable tuning. I'm not trying to, no one can hear the difference. People hear bad unisons. Nobody hears when a note is 1 cent off. So, I just encourage you not to go crazy on Smart Tune because it's kind of magnifying the changes that you need to make, and you want to make the fewest amount of changes that you can get away with. Yes?
So, will you show me how you set that?
Yes, show them how to do global pitch.
Okay, this looks just a little bit different in the iPad native version.
You can use it on the iPhone if you want.
But you can do it on the iPhone. The iPad native, it's real similar. You tap on the A440 at the top, and then choose your pitch right here. You can choose it in hertz if you want. Like, for instance, what Carl's talking about is about a 440.5 or so, which is about 2 cents sharp. Or you can choose it in cents, which is, he might want 1.5. Whatever flavor suits your fancy.
So you just added that cents in there, didn't you?
Yeah, I just added 1.5 cents, and in this case I hit the
No,
hit
it's
done.
always been there. You can toggle.
No.
Students used to show both hertz and cents.
Yep, they're both
Always
there.
did.
Yep.
You have to toggle. Let me look over here on the screen.
It's been there for many
If I
years.
touch hertz, it's hertz. If I touch cents, it's cents.
Oh, I see.
It's actually got a built-in hertz cents converter for if you ever want to use it.
By the way, everyone, if I go back to Chameleon, I don't know how many of you know this. This is an interesting thing. When you're in Chameleon and you see a pitch above all of the notes, 4 of them are in cents, but the blue one says 441.2 above A. If I want to toggle, if I want to see that in cents, if I touch it, it will toggle between cents and hertz, only at A4. So you can have it displayed either way that you want. And this brings up just another thing. These cents that you see in Chameleon, we call this smart pitch. What do these numbers really represent? In other words, if I had 5 tuning forks for A1, A2, A3, A4, would these notes be those amount of cents above the tuning forks?
No, that wouldn't be a meaningful number.
No.
What we want is what CyberTuner's doing for you behind the scenes is saying, okay, if this guy hits the calculate button right now, what tuning would he get? It calculates it behind the scenes and then says, okay, how far are we off from that calculated tuning? So it's the most meaningful number that it can be.
Because that's the pitch correction you're going to do. You're going to correct between where the note is and where you want it to be. That's what's important to you, not some arbitrary standard. Yes?
So,
Sometimes I've measured A's and a number 2.7 has changed to 2.8 after I measured
right,
that.
and that's because you changed the tuning style. The tuning style changed the target, and that actually changes how much you have to how much you need to raise the piano or move the piano.
Wait, let me finish with this answer and I'll get to you after. It's more than that. It's what he said earlier. So you measure A4, you measure A3, and it says plus 2.7. And now you measure A2, and the 2.7 changes to 2.8. Okay? That happens quite frequently. Why does that happen? What Dean was saying to you is as you sample each A, it's computing a target tuning with first only one note of information. Second with 2 notes of information. Now you've got 3 notes of information. The target tuning it's creating changed that second sample.
So it's refining.
Oh,
It's refining
okay.
it as you go.
Okay, I thought you meant you changed to OTS, but no, yeah, exactly. It's refining the target and then refining that sense offset as you go and record the piano. It actually doesn't matter. You can choose your tuning style before or after, and Chameleon doesn't care. It won't affect the quality of tuning either way.
In other words, all that matters is what octave tuning style is chosen before you hit calculate. What's different, if you do it first, then these numbers of these kind of intermediary calculations will change as they should for that octave tuner style. If you wait until after you've sampled, you won't see them change because it'll comport with the final tuning style that you've picked. But in terms of calculating, it just matters that you pick your octave tuning style before you hit calculate. Ashley.
What I want to know is if there's any difference in choosing your overpull amount by going to the 440 device or by choosing in the overpull box on the
in fine-tune mode,
I'm
in
not
fine-tune
understanding the
mode,
question.
you have the offset box. It's exactly equivalent.
It is exactly
There is no difference, but I would caution you not to use the offset box. The pitch, global pitch up at the top is global. It's changing the pitch for every note. Offset is also global, but it's meant to be used for individual notes. So in other words, you're globally tuning to 1.5 cents. You come to A5, A6, and it doesn't sound right to you, and you want to offset it by 1 cent. That's when you use the offset button. The reason is it's not in your face. You can forget that you added it. And so when you add the 1.5 cents or you subtract 1.5, and the offset button, it's not staring you in the face like it is up at the top all the time. So it's the same, but it's just less mistake prone to use the global.
So what's happening here? I've got 1.5 cents. I'm tuning 1.5 cents sharp to A440, but I'm actually tuning 1.7 because these two add to each other. I've set. For instance, I could set, and there are. You should be careful that when you do that because you may forget that you've set an offset there. That's the problem.
Well, the way that I tend to use that is if I'm touching up for a concert after a sound check, and I want to know where my A is.
Mm-hmm.
Because maybe they turn the air on.
Yeah, I do the same thing. Like, for instance, I might set that to 442 up there, and this is how I would use it. I might want just a little more because my A is moved up, so I'm going to tweak it up 0.2 cents because that's where my A is done, 0.2 or 0.3 cents.
And I listen to where my A is, and wherever that is, then I do the tuning there, and then it always, when I go back and it says, oh, do you want to reset to A440? You've got that.
It reminds you, yes.
So that for my next.
Yeah, it reminds you, and
Now,
it'll
you're
warn
using
you.
it exactly the right way. It's meant to use the right listener ear and have that number then display in the offset box by how much it's offset itself, and that you're using it the absolute optimal way.
Here's a pro tip. If you use the right listener ear, play the note and it records it, you get 0.30, and it's still a little bit off. You can hit the right listener ear again if you want, but if you swipe up or down right in the spinner, you'll get another 1/10 of a cent. So it's in the manual. Believe me, it's in the manual.
Nobody reads the manual.
Okay, if you do 2 fingers, it'll do 1/10 of a cent, 1 cent.
Wow.
So it's a pro tip.
But I know. But listen, I really would caution you because when you're doing this after the sound check and you're just going over and making sure that the thing is, you don't really want to care about 1/10 of a cent. You don't even want to know about 1/10 of a cent.
I mostly just do unisons. I don't even always use the software, but
Right.
I've had occasions
Right.
where
That's what-
changed a lot.
Yeah, it happens. And as you said, it's the air conditioner, it's the stage lights, it's things like that. But are you really, I mean, frequently I do the tuning, they do the rehearsal, everyone's happy, I come out for the sound check, and something has changed. You know, I basically clean up unisons by ear at that point. That's all I do.
Well, that's all you have time for.
Yeah.
It's the most important thing.
Yes.
While we're talking about offset,
Yeah.
can you talk a little bit about how to modify a note in a saved tuning? Is that using the offset box?
No.
It's the left offset box.
It's the tune box, not the offset box.
The tune box. In other words, you can go into that tune box, Dean will do it for you, and it works the same with one finger, with two fingers. You can do whatever you want. And if you had Nate wants to come in here.
Does it only work in fine-tune mode or smart tune mode? Part of that?
You really
works in
should
both, actually.
You really should be doing that in fine tune mode though,
Right.
Because in smart tune mode your overpulls are going to get in your way.
And so once I do that, it's then saved?
No, it asks you to save. There's a save button, there's an S button. And in other words, when you're changing the permanent tuning record, it makes you do it twice. Do you really want to change your permanent tuning record?
When it automatically changes a note, it doesn't affect that next note in any way?
In any way. The left tuning box is what you're tuning for that note.
Okay, thank you.
That kind of reminds me of a question I was going to ask earlier.
Sure.
When we were looking at Chameleon there. What's the advantage of, short of an unusual tuning where you have one particular note that just doesn't sound right or something, what's the advantage of saving a tuning and loading that as opposed to listening and resampling a piano each time you visit?
Okay, so I work on a lot of pianos over and over again. Okay, and I believe the most important thing in tuning, it's like real estate, stability, stability, and stability. Everything I do, I'm thinking stability. I think if I put the same tuning on the piano every time, maybe the conditions have changed, and if I sampled it, it would be ever so slightly different. But that's less important to me than doing the same thing over and over and over again. So when I've got a good tuning for a piano, I don't resample the piano. Now, one exception. If it's a really unique weather condition, if you know I created it when it was really dry or I created it when it was really wet, then I might resample it.
To establish whether or not you want to save that tuning, you just, if everything pops up green in your sampling session, then you just save it.
I save every tuning.
So I completely agree with Carl, but the key point was special weather conditions, and I live in Toon in Michigan, and we always have special weather conditions. So Carl lives in piano tuning heaven where the humidity is low and it's just like this all year long, almost exact same thing, and pianos don't go out of tune anywhere near as much as they do here or in Minnesota where my friend Mitch tunes or in Michigan. In Michigan, I mean, everything he's said is absolutely true, but they don't apply to special weather conditions. For instance, if I tune in the middle of summer when it's 117% humidity and 92 degrees, and then I go back and I save that tuning, and I go back in the middle in December, when they're not humidified, it's 15% relative humidity inside, and the piano's gone down 30 cents in 6 months. I mean, that's a realistic condition. That saved tuning doesn't work very well, so I'll re-record. If it's a situation, I do save tunings, but I pay attention to the weather conditions. If in the case where I'm tuning for concerts, I save the tuning because I agree with him. Stability, stability, stability. So I'm saving the tuning on Thursday for my rehearsal because I'm going to be tuning that piano on Friday for the concert, and then for Saturday in the concert. And the weather's not going to, even in Michigan, the weather's not going to change in 2 days enough to worry about. So I'm saving the tuning from Thursday to use on Friday and Saturday, and then I get stability, and I'm tuning to exactly the same tuning for every note in the piano, and I extract my stability out of that piano as best I can.
So let me show you something really.
Mm-hmm.
Let me show you something. This is so up here is a tuning that I do all the time. This is for a CP70. It's for the group U2. They carry this CP70 around.
What's this blip around A?
And there is one note. I don't know if someone at one point replaced the strings. I don't know what it is, but there is one note that I've got tuned a little over 10 cents sharp.
This note, this is
And because I went
is
and
crazy.
I played the piano. There's a second note also, where I played the piano afterwards, and there was this from D to D. It was just a horrible octave in the middle of the piano. And I just corrected the note by ear, tweaked it in as well as I could, and recorded it. And that's the permanent record.
This is
and
not
it never changes.
This is not a normal tweak, though. This is not. I mean,
what I'm saying is sometimes, and and they know it. They said, tuners have told us that there's a couple of notes on this piano that are really weird. And the answer is there's a couple of notes on this piano that are really weird. So I'll just tweak it by ear and save it and put it in the permanent record.
To continue and to go along that strain, continue the question you were asking earlier. To save a note, you have to have it calculated. It has to be from a file, and to save it, let's just say this G sharp 4 I think should be. I've listened. I've determined it should be just a little bit sharper, say 1 cent sharper. I'm going to change that. I can use the listening ear and listen to what I tweaked it to, or I can just change it up 1 cent. It's save, and now to actually save it to the.
So yeah, how do you get that window?
Oh,
just touch the box.
Just touch the box and it pops up. On the iPhone version, it actually slides over to a whole new screen, but it looks exactly the same as this, pretty much. Yeah, Toon box. Okay. Yeah, I just changed that. But to get the Save Sense button, you've got to hit the left listener ear, and then now I can hit Save Sense, and that's going to save it to the tuning record. That's going to save that 1 cent tweak to the tuning record. You can actually save a whole 88-note tuning this way. For instance, if you have an 88-note oral tuning, you could save it right into CyberTuner and repeat it if you wanted to repeat an oral tuning. So, is it live? Or is it Memorex? At that point, that's one of those procedures. You either need to read the help or you need to read the manual. I think in that case you actually need to read the manual. To do that procedure. It's pretty simple, though. Recording a piano, I can record a piano in about the whole 88 notes in about 12 minutes, accurately, real accurately, within 1/10 of a cent or 2/10 of a cent. There's always just a little variation. The gold standard is to get it within 3/10 of a cent. So, right, I got good at it doing exams. So,
do you have your laser? Can I use your
Yep.
laser? So I'd like to talk. What do I do? Just press.
Yep, there you go.
Okay. When you're at the chameleon screen, let's go back just for a second. I assume most of you know how to do this. This is the chameleon screen. Up at the top left, it says Advanced. I'm going to touch Advanced. There's some very interesting things in these preferences, and I'd like you to be aware of them. Most of the time, you're not going to touch this. You're going to let Smart Chart, CyberTuner will pick the right partial for the right part of the piano. But if for some reason you want to override it, there's some reason, what you can do is turn it off one time. It'll let you then go in and manually adjust the partials, and then the next time it'll come back on again. It's not something that many of you are probably ever going to do. If we can go back to Advanced. The thing I would like you to look at is low bass smart partials. Standard, or if Dean touches it, there's low stretch. What this basically does, this is what we found, is Atsundo, represents us and teaches in Japan. And he's got contact with a lot of really excellent Japanese piano techs. And they like less stretch in the bass than we do. I've talked with Leroy Edwards about this, and Yamaha is really big. If you look at I could put it up, but if you look at the Yamaha stretch for a CF Grand, the 9-foot, they only go down to about -6 cents at A0. They want much less stretch than we do. They like really clean octaves. But if you want to try that mode in a simple way, just switch to the low stretch thing, and it'll make all of your partials one partial less than the bass. It's an easy way to just test a cleaner stretch.
All that does is in the lowest octaves, it does slightly lower partial matching, which gives you just slightly more conservative stretch, slightly less stretch, and it'll consistently do that from then on. So,
the other thing I'd like you to look at is the global A4 pitch. Most of us tune to A440, but if you work in a concert situation, it may be pitched to A442. If you work on Bosendorfers, it may be A443. You can change the global pitch here to any of those, 440 to 443. And when you go into the, if I do it here, if I set it for 442 and I come back and I now go to Cyber Ear, look what happens up at the top of Cyber Ear. It's at 442. And every time I turn it on, it'll be at 442. So if you're in a situation where you globally turn, you tune to a different pitch, you can define it here in these preferences and not have to change it every single time.
The other thing it does, if you tune regularly to a non-A440 pitch, and you want to set that, it'll stop warning you when you're at A442. It'll only warn you. Let's say you set it to A442. Cyber Ear will only warn you when you're not tuning to 442, instead of being annoying and telling you all the time you're tuning to a non-A440 pitch. So it reduces the amount of annoying messages you get, and it keeps you on the right pitch, whatever pitch that is you've chosen to be your standard pitch.
So something we did this year, in almost all of our menus, we simplified them. There's a lot of controls. There's a lot of things that you can go in and take the gears and levers, and you can tweak this program in very idiosyncratic ways. And I encourage you to do that. But for most of us, we're not going to do that. The defaults we've picked are very smart defaults. So what we have is this Show Advanced Control buttons. And it's in virtually all of our screens now. And if you turn it on, it asks you, these are advanced controls, do you want them? And all of a sudden, there's more things that you can do. You can control the arc, you can control the speed, you can control the color, all of these things. I've tweaked my spinner, so my spinner looks a little different than everyone else's spinner, okay? It doesn't make it better, it's just sort of what I like. If you want to tweak your spinner and customize it, this is where you do. But if you don't want to even see that menu, you don't need to see that menu, you can hide it. Yes?
Where are you?
So, let me go back. I'm in tuning modes, okay? I'm in the standard screen.
Go back to Cyber Ear.
So let me go back to Cyber Ear.
So he's going to hit the tuning.
I'm in Cyber Ear, and you see where it says, under the icons, it says Mode, Fine Tune Concert.
Okay.
I'm going to touch that box, and it's going to take me to the tuning mode screen. This is where you either turn concert mode on and off. Just FYI, let's just talk about concert mode for a second.
Okay.
This is fine tune, and let's look at the circle. The big gray circle is 10 cents, and the darker gray circle is 4 cents. It's a very narrow window. This is concert fine tune. The spinner is spinning 2.5 times faster than fine tune.
So concert mode isn't necessarily better than fine tune mode. It isn't necessarily going to give you, it's more appropriate for pianos that are extremely close. Yeah.
It's essentially a magnifying glass,
That's
but it's
exactly
more,
right.
it is more than a magnifying glass, because it's also, I tend to use a faster spinner speed. So the blushes happen in a narrower window. And it's set up for a faster spinner speed. I tend to use a fast spinner speed all the time. That's something that I've customized. In theory, it's better to have a faster spinner speed because your windows of blush are narrower. The thing is, you have to have the hammer technique to be able to make small enough adjustments that you can get the blush. Otherwise, you're a very, very frustrated camper. So a lot of the spinner speeds are set, I think, a little bit too slow. And if you want to challenge yourself, start to move the spinner speeds up. It'll slow you down for a week, but you'll be better from that point on. It's a real eye-opener. You think you're making these really small adjustments, but when you speed the spinner up, you realize you're not making small enough adjustments.
So how do you speed the spinner up? One way is to simply turn on concert tune mode. Carl always has it set super fast, so it's concert mode only oh my goodness. So concert mode actually does change the numbers, but only a little bit for Carl.
Yeah.
My copy is sent to the defaults. So when I turn when I turn standard fine tune or smart tune mode on, I get fast speed of 1.7. But if I turn concert mode on, it goes all the way down to 1.0, which is much, much faster. Not quite twice as fast, but almost.
So does concert mode then change the calculation?
It doesn't change the tuning calculations. All it does is it changes two things only. It changes how fast the spinner is, changes from, as far as the defaults, from 1.7 to 1.0. And
In other words, where the blushes are.
And it also changes the size of the spinner, how magnified it is, from 25 cents, plus or minus 25 cents, to plus or minus 10 cents.
And it also speeds up how
Blush.
that spinner responds.
It does speed up the spinner, but it also slows it down because when you're in concert smart tune mode, it has to be more accurate. In other words, when you're overpulling by 10 cents, you know, if you end up plus or minus a tenth of a cent, it's not critical. If you're overpulling for a 1.4 cent pitch raise, that extra 1 or 2 tenths of a cent is critical, so it listens longer. So it speeds up some parts and it slows down other parts.
Yeah. If you have a piano that's 1 cent off and you're doing a smart tune pass, it's going to be a little slow. You're probably going to want to just switch it out of smart tune mode, because when you're 1 cent off, the piano's 1 cent off, the overpulls have to be extremely accurate, so it's got to take longer to record the original pitch. So, yep, question right here.
Back in the day, your basic instructions would say, okay, well, first make sure your A's are at 440 and do that, and then take your samples, because it might be all over the place. On the other hand, if we're tuning for a Lyndon LaRouche disciple or for an early music festival, is it required or is it advisable to first yank these things up, or whatever your low standard is, Cybertune is figuring it all out?
You're talking about
great question, Pat.
In Chameleon?
No, he's talking about in Chameleon when you're recording. First of all, never change the notes just to sample them. Okay? If you're working on someone who has the music of the spheres at A432, we've all been exposed to this. People who you know, the Nazis put A440 on us, and we're all jumpy and crazy because of it. But and if you have to tune to A432, if you have to, it's better to sample the piano around A432, okay? Because when you're within 10 cents of the target, it doesn't matter. But when you're within 40 cents of the target, it does matter. So in that situation, okay, for my first pass, I think I might just sample it and do a 40-cent pitch lower. This is what I have done. I've had to do these for people who request this for recordings. And I push it down to 432. Then I resample the piano for my second pass.
This is how flat. If you're tuning into A432, CyberEar's got a converter in here. You're almost 40 cents flat. So that's a huge change in harmonicity. If you sample it 440 and then move the piano down to 432, the tuning's wrong for 432.
And I will say, as you know, I don't try to, if someone is in their home and they ask me what I think about this 432 stuff and should I put it on I try to talk them out of it. In a polite way, I tell them it's a bunch of hooey. If I'm in a professional situation where someone requests it and requires it, my job is to serve them. And I think if you're using CyberTuner and you're using this new improved pitch lowering function, I think you'll do a better job doing this A432 tuning than any of our competitors. Okay? But for the final tuning, sample at the pitch you need to be at. For when you're making a big pitch change, it's not critical to get the first tuning perfect.
So let me just quickly, if you have the current release version 7.60, you can go in there and do what our next version will do, which is adjust the underpull to -2. And in fact, I'd recommend you do that. That's what we found is the best underpull. And that's, you simply go into Smart Tune, and Advanced Controls, go down to Adjust Overpulls and set it to -2, and you just tweaked it. So the next release will automatically adjust you to that.
That'll be the default.
Adjust underpull to
-2. Yeah.
To make up for the asymmetry between overpulls and underpulls.
That's the best starting point for for compensating for that asymmetry. If you find that your tuning technique and the pianos you tune wants -3 or -1 or 0, you can go with that. Once you've set anything on here, there's a switch at the bottom. It's a one-time deal. Hit that save percentage as default, and it'll save all those as your default from then on. So, question.
I have a question about committing in advance and the Toon partial set. Is there a setting for that? Or?
So this is what we call smart partials. The setting is on. The setting for that is on. And that's the default. That's what you usually see.
Should we set it as the default?
You should leave it to on 99% of the time because the program is really smart and it's going to choose the right partial set for that piano.
So save adjustment percent as default. I want that on.
So
Yes.
if you see it here, it's set to on. And that's where it should be. And when it's on, CyberTuner is tuning to one partial, but it's listening to multiple partials. It's listening to multiple partials in Chameleon. It's listening to multiple partials in CyberEar. And it's balancing things behind the scenes. It's making gazillions of calculations that you're unaware of. I mean, it's really amazing. So when you start to create a tuning and you're using OTSP or using OTS5 or whatever you're doing, CyberTuner is looking at what's the best way to make a good transition across the tenor strings to the wound strings. What's the best way to make a transition between the tenor strings on the low bridge and the middle strings. It's looking at this and it tries out the third partial, it tries out the fourth partial, tries out the fifth partial, tries out the sixth. It looks at what's going to make the smoothest transition, and that's the partial it picks. So when this is in the on position, the CyberTuner is choosing the partial for you. The people who turn it off are people who are either doing research or people who are so advanced that they have a reason for telling CyberTuner to pick the partials that they want as opposed to the ones that CyberTuner wants. Okay? Since we've instituted this feature, I can't think of a time where I went in and said, oh my God, CyberTuner, what are you thinking about? I'm going to overrule you. Okay? It's a very smart feature, so let it make the choices. We've had a situation, Kent Swafford, if you've seen his articles, on Pythagoras, an amazing set of articles. Kent, aside from being a great technician, is a researcher. He's a scholar. He's doing a lot of research on all of these types of tunings. And so he's the sort of person who goes in there and turns this off and tasks CyberTuner to use specific partials because he's like doing research on how the different partial pairs match up. That's what it's really for a super advanced user. It's way more advanced than I am. I just leave it on. Another question, yeah.
Could you pull up the save percent as default screen again, Dean?
Sure.
Once you slide that tab, just let's say adjust article minus 2%, and now we've saved it. Can you then change that for if you change?
What it is a one-time save, and it's going to save whatever those sliders are set to right now, and then that switch is going to go off, and you can change it later. If you make another change later, it's going to be a temporary change unless you hit save its default.
And in temporary changes in one tuning.
One tuning. Yep, that's right. So
that's going to go back.
That's correct. The save at default is when you tune another piano, it's going to go back to your defaults. We have a number of settings like that where we want you to be able to customize the CyberTuner to match what you want it to do, and then for the average piano, but you want those defaults to go back every time you tune a piano. But there's occasional pianos where you want to adjust things, and you want to adjust just this piano, and you want it to go back to your defaults for the next piano.
I guess what I'm trying to say, if you slide the adjust under pull right now, what happens?
I can still adjust it.
And so now for this tuning, it'll be at 0, and as soon as you re-record, it goes back to it.
That's right. That's correct.
So one other thing, let's look at this graph up here. This is this Steinway B that I sampled and put a tuning on so I could tune the C's and the G's on this piano, okay? Look at what's going on with that blue line. Around A6, it was going somewhere and then it got pulled, and that's because it's a 9-foot piano and that's because it's pushing it towards 19ths. Lots of times I don't like that discontinuity. Okay, so if I saw this on this piano, I would probably go in and set the slider to -2 for this piano and smooth that curve out.
What slider are we talking about, Carl?
The high treble adjust slider, this slider. When I go into Chameleon and I go into here at the bottom of it, it is high treble adjust, and it's its standard. I would probably move that to -2. And for instance, let's just say we calculated that tuning with -2. Well, it didn't do much to change that bend.
Did a few cents.
On this piano, it didn't help that bend. But on lots of pianos where you've got that kind of discontinuity, that's when I might play with the high treble slider and try and smooth that curve out. That's just something I might do. And it brings up another issue. For me, what? Go ahead.
So notice CyberTuner is showing us this is a pure 12th tuning. There's a P in the header, and it also says -2.0, just reminding us that we used the high treble slider set at -2 for that tuning.
And again, I'm just sharing, this is a prejudice that I have. I practice what I call defensive tuning. When I'm in someone's home, my number one goal is to not be called back again. Okay? I mean, I want to do a good tuning. Of course I want to do a good tuning, but my number one goal. So I may kind of pull it in a little. On that piano, which is up at plus 55 cents, if I were in someone's living room, I might put -3 and bring it down to 46 cents. I just might want to kind of bring it down more towards the middle because I don't want anyone complaining. When I'm on stage and the piano has to last for 2 hours, I'm kind of my most aggressive. I'll do the most stretch that I'm ever going to do. I think big pianos on stage carry better when there's more stretch. And it only has to last 2 hours because I'm going to tune it before the next concert. So I'm really aggressive. One of the things I would just suggest to you is that you start to think about where it is that you're working. I work a little differently in a home or a recording studio or a stage. I'm more conservative in the home, middle of the road in the studio, and more aggressive on the stage.
You get the window where you can move that.
Okay, so we go back to Chameleon, the main Chameleon screen, and up at the top where it says Pure, I touch that, and at the bottom of the octave tuning styles, all the octave tuning styles are there. At the bottom is HTS Adjust. And then also save it as a default.
And I just put it at -4, and it cured the
And it
little
cured the
blip
bend.
on that particular piano.
Yeah, okay. Thank you. That's really good. That's actually a button that's very useful to play with. And one of the things that Dean and I have been talking about over breakfast today, I think we're going to put in a low bass adjust slider also. And let you just basically directly go in and tweak the bass, tweak the treble, see how it looks. I think it's going to be a real popular feature.
Because the low bass and the high treble are the two areas where piano tuners tend to disagree the most. The middle 5 octaves, we kind of, especially on pure 12ths, we kind of agree almost universally that sounds fine. But when you get into the highest and lowest octaves, it's not so much the case. And so that's where we need a little more adjustment. So.
Yes?
Where does the OTSP fit the
other 9? It's okay. It's what we would call sui generis, which means a genus unto itself. Okay, it's a one of a kind. What the octave tuning styles are getting from narrower to wider by how they stretch the middle 2 octaves based on octave pairings. Mostly the 4-2 octaves get wider and the 6-3 octaves get wider. And so that's the metric. It's based on the 4-2 and the 6-3 octaves in the middle of the piano, 9 being the widest, 1 being the narrowest. OTSP is not looking at the octave pairings at all, even though it will display it in the header. It will display a T reading, in other words, the width of A3, A4 at the 4-2, and it will display a B reading, the width of A2, A3 at the 6-3. But that's not what it's using in its calculations. It's really blending the 3-1, the 6-2. It's blending 1.23 wide octaves. It's blending 0.62 wide double octaves. All of the things that are indicative of pure 12ths. And that's what it's using. And the reason that it's so unusual, I think, is it uses the same amount of stretch everywhere on the piano. We're trying to put the pure 12ths everywhere. And one of the things that good tuning is, if you're in a situation where you play a note, you end on an arpeggio on C7, and then you play C1 as a final note, and do they sound in tune? That's really good tuning, makes both the top and the bottom of the piano sound good together. That's something that OTSP is trying to do.
Yeah, it doesn't really fit into as Carl says, it doesn't fit into the numeric. I tried to fit it in when I first started calculating this, and we started listening to it. Well, is it closest to OTS 4 or 3 or 2 or 6? It varies. Parts of it might be anywhere from 2 to 7. So you can't put it in the middle. It's not an extreme, but it's in the middle. But you can't pin it down.
It's sui generis.
As you look at it,
Different pianos for one, and also different parts of the piano. It actually uses Pure 12th is going to use less stretch than you probably expect in the bass, and a little bit more in the treble. I guess that's the most general most general statement I can make about it. But it's going to use the right amount to get the fifths and the octaves exactly the same beats, and that's the important part.
Ashley.
Could you talk about the iRCT exam feature? I don't know if that interests everybody.
Sure. I can, real briefly, I can, but the best class to take is Mitch and Mary Keel's class tomorrow. They're going to talk about they use several of the tuning devices, all 4 actually, but they show Cybertuner's ability to do a mock exam and get you all the way to using Oral Tutor, which is it critiques your tuning orally and tells you in oral terms which notes are off, how much they're off in oral terms, and which intervals are the worst off and how to fix them. So,
but I think your question, if I can take you want to know just what OTSE really is.
Is that what your question?
Well, I want to know, why should I use it?
Okay, so let me tell you what OTSE is. And Dean can get me. Dean has given hundreds and hundreds of exams. And so what OTSE is it's trying to mirror what the classic master tuning is. The classic master tuning tends to have a little bit less stretch than we used to put on in the middle, and a little bit less stretch up at the top. When we're doing something like OTS4 or OTSP, we're doing wide double octaves up in the 7th octave, okay? For most master tunings, that's considered too wide. They're closer to single octaves.
For the purpose of the tuning exam, that's considered a little too much stretch on the treble, high treble. So if you're taking, in other words, if you're taking the tuning exam and you're going to use Cybertuner in the outside the mid-range where your oral's required, use the RPT tuning exam, OTSE, and you have the highest probability of getting the best score with that tuning style.
Chris, and go ahead.
Carl, we've gotten in this class used to looking at these graphs. Can you, with this Steinway beat that you recorded, calculate an OTSE tuning?
Yes,
sure.
Yes, I can. And let's go to, it's right here, OTSE, and let's calculate it.
Now, you're taking an existing calculated from something else and calculating it for a different...
No, I'm taking this Steinway B that I just did.
Look how low that is.
It's
Yeah,
huge.
the high
In other
treble
words,
is really
OTSP
different.
wanted it 55. OTS 6 wanted it 48, but the exam wants it at 31. And this is a note to you taking the exam. Most master tunings are splitting the difference between single and double octaves up in that 7th octave. It only goes up to A7.
What they specify is pure single octaves up in the highest octave, but that's not actually what they do. What we do, and I've measured this a number of examiners, what they do is they roughly split the difference between the single and double octave because they can't quite stand to tune single octaves. They're just too flat. So they don't do exactly what they say they do. This is what they do on average. It varies a little bit, but
Yeah.
Could you tell me the meaning of the small print in the file?
Yes. That's called the header, okay? And what it has to do, in all the numeric tuning styles, we create a tuning based on oral principles. In other words, just like if you were doing it orally, you might do the A3 to A4 octave, set it as a temperament octave, set the A2 to A3 octave, set it as a temperament octave, and make sure it fit within the A2 to A4 double octave. So those numbers, when you see B equals, that's the beat rate at between A2 and A3 at the 6/3 partial pair. When you see the T, that's the beat rate between A3 and A4 at the 4/2 partial pair. And when you see the D, that's the resultant width of the 4/1 double octave between A2 and A4. That's what.
Just the intervals I played are the beat speeds that's describing. They're oral beat speeds.
Is that in your book?
Yep.
All of this is covered in the manual. It's all covered in the online help, you know, on the little I button.
Basically, that defines the stretch.
Yeah.
That's defining the global stretch. And remember, we do something in OTSP very similar to what we did in the numeric things. There's a global stretch, and then there's an extra little kicker of stretch in the top and the bottom based on how wide the stretch you pick is. So for instance, if you picked OTS 4, you'd be tuning pure double octaves up to A7. And if it was a 6-foot piano, let's say you'd be using the 7th partial in the bass. If you pick OTS 7, okay, it was a Steinway B, you're going to be 3/5 of the way between a pure double octave and a pure triple octave up at A7, and you're probably going to pick 10 in the bass, and it's going to be more stretch in the bass. So when you use bigger stretches, not only do you get more global stretch, but you get an extra hit of stretch up at the top and the bottom. And it's the same thing with OTSP. We do the same thing. Yes?
So did you just take an existing tuning and change the...
I did. I took the sample for this this Steinway B that I did earlier.
And you just sampled it, though. That's the only reason you were able to do it.
Correct.
It's still stored in...
It's exactly. The samples are still active. They're in the 5As.
Yeah. Once you record, you can sample. You can recalculate any number of tunings.
You have to sample something else.
Right.
As long as you haven't sampled something else. Exactly. Yes.
I've had problems with small pianos, small pianos. There's this Curveball mini grand piano, that from the break to the higher end, you know, any of the stretches that I've tried, because I've tried like 4 in the same piano, it works pretty much. But when you go down, with any of the stretches works. So I usually end up doing orally, you know, like the end. But I know that the problem is the piano itself, you know, the scale or whatever. But is there something that I could kind of do on the, you know, so to solve this kind of problem that it's following?
I'd probably have to see the tuning calculations that you've done and look at it. I can kind of tell, but generally in those kind of pianos, I'd still recommend the pure 12ths. You try the pure 12ths. It's probably going to do.
This is the first thing that I tried because I love when I use it, and it works pretty fine for most of the piano. So I just tried on that one, especially the best, but it didn't work out at all in the bass.
Well, let me say, you know, listen, this is a great tool. It's an amazing tool. It does amazing tunings. But there are some situations where you're at the limit. On these really small 5-foot grands, those are the most badly scaled pianos. The CP70s, the Yamaha electric grands, I actually have to override Cybertuner with my ear. It just can't handle. It's expecting a certain structure of piano. And on these pianos, which have such terrible inharmonicity, you may actually have to override an octave's worth of the tuning with your ear. And you'll pay a price for it, but that's what we do. We're piano tuners. Yeah.
If I were in your situation, it sounds like I would tune it orally, which you've done, and then record every note, and now you have to save a file, and never have to think about it again.
You're
very good
You're
approach.
probably better off to take an approach of calculate your best tuning for it and orally check very carefully with oral checks across the break. That's usually the problem, right? Just below or just above the break. Tweak those notes, but probably don't want to change them more than about a cent. If you're going to change them more than about a cent, make sure you listen to at least 3 oral intervals, because Cybertuner's already done a compromise, and you might be listening to one interval and you might say, oh, that's not quite right. I'm going to correct this. And what's happening is you're making another interval even worse because it's split the difference between 2 intervals in a lot of cases. So make sure you check at least 3 oral intervals before you
But there are,
record that
and
change.
this is, by the way, one of the things that we're talking about of slightly tweaking the OTSP calculations across the break at small pianos, because we agree with you.
What we found is the small pianos like that in pure 12ths need just a little bit wider single octaves, and we're going to be able to cheat the pure 12ths just a little bit, tiny bit wider, because those pianos need it. Okay, it's just a question of do you want to compromise the octaves or the 12ths or the 5ths? I mean, everything's a compromise.
So we've reached the end of our 90 minutes, and we really thank you so much for coming. I really thank you.